Hello and welcome back. Today our mastery learning objective is I can simplify rational exponential expressions by applying the properties of integral exponents to rational exponents. So first of all, we are going to start by writing out our fractions here in expanded form. So we have 5 to the 6th power, so it means we're going to write 5 multiplied together 6 times. And on the denominator, 5 multiplied together 4 times. Then we can cancel 1 on the numerator with 1 on the denominator, because those are just equal to 1. When you have 5 over 5, it's just 1. So we have 5 and times 5 left on top, so we'll write that as 5 squared. Same idea for number 2 here. When I cancel these, 1 on the numerator, 1 on the denominator, I'm left with a to the 3rd power. There's 3 a's left on top. Number 3, we have 8 over 4. Those coefficients will stay and we will simplify those later. We have 7 a's. 1, 2, 3, 4, 5, 6, 7. And 8 b's. 2, 3, 4, 5, 6, 7, 8. On the denominator, we have 1a. There's a 1 exponent here and there's nothing written. And for b, there are 5 on the denominator. Now we start canceling. So the 8 over 4 can be simplified to 2. A on top, A on bottom cancel. B on top, B on bottom. We are left with 1, 2, 3, 4, 5, 6 A. So A to the 6th power. And 3 B's, so B cubed. So 2A to the 6th, B cubed. Number 4, this 2A is what is written 4 times. So 2A times 2A times 2A times 2A on the numerator, all over 4. And then A to the 2nd means we're writing 2A's, multiplying 2A's on the denominator. So when we simplify here, we have 2 times 2 times 2 times 2 on the numerator, which is 16. We still have 4 A's on the numerator as well. 4A times A on the bottom. So what I did is I just took those coefficients and brought them out front, so it was easier for me to simplify. So now I know it's 16 over 4, which is 4. I cancel A here, A on numerator and denominator, and left with 2A, so 4A squared is our final answer. Just a reminder that if I'm going too fast, pause the video and write down. Okay? I'm going fast on purpose so that you can pause the video and then play when you need to. If you haven't noticed up here, there's a pattern going on, and that pattern is the quotient rule. Right? So what that says is when you divide two numbers, like this a to the 5th, a squared, with the same base, you subtract these exponents. So 5 minus 2 here, that's how we got 3, and that a base stays. So let's do that with some of these examples. Number 1, 2 to the 2nd power over 2 to the 4th. That will give me 2. I keep the same base. Subtract the exponents, 2 minus 4. So we have 2 to the negative 2 power. And we'll see later that we don't want a negative exponent, but for now we just leave it as 2 to the negative 2nd power. Number 2, our base is 4 and 4, so we keep the same base of 4. The numerator 4 is raised to the 1st power, and the denominator 4 is raised to the 4th power. So our exponent is going to be 1 minus 4. So it's 4 4 to the negative third power. I'm going to skip to number 4. Number 4 is x and x would be our base. We have 3 minus 5 as the exponent, so x to the negative second power. If you want to try 3 on your own, you should get 3 to the fourth. Like I mentioned, this we're going to have this negative exponent rule now, and we also have the zero exponent rule. So zero exponent's easy. Any number raised to the 0 power is 1. Okay, and we'll see that later on. And then negative exponents, we don't want a negative exponent. So what we do is we switch it to either the denominator, or if it's on the denominator as a negative exponent, you write it as the numerator. So let's look at some examples. Number 1, in parentheses, we have negative 5. Okay, and we have this negative exponent. We want to get rid of that. So negative 5 will stay. I'm going to give myself some room. Negative 5 will stay the number. The negative on the 5 doesn't change, but we want to get rid of the negative on the exponent. So what we're going to do is put it on the denominator. That makes the 4 positive for the exponent. And since there's nothing on the numerator now, we leave it as 1 over, parentheses, negative 5, close parentheses, raised to the 4th power. All right, again, keep in mind that the base sign does not change. The exponent sign changed here to here, but the base sign did not change. Number 2, this is quick and easy because it's a number, which is negative 1/2, but it's raised to the 0 power. It's just 1. Anything to the 0 power is 1. Number 3, our base is 3/2. We have a negative exponent, so we want to get rid of that. Right, so it's going to go on the denominator since it is on the numerator. So 3/2, that will make a positive 3 exponent, and 1 will be our numerator. Right, we typically don't write something like this. So if you get this answer, you shouldn't leave a fraction like that. So what you can do here is take 3 to the negative 3rd power. So I'm taking this negative 3 and distributing it. And then 2 to the negative 3rd power. Okay? And now what's going to happen is we're going to take this 3 raised to the negative 3 power, and it's going to go on the denominator. So 3 raised to a positive 3. This base 2 is going to go on the numerator, and the 3 as its exponent will become positive. Okay, and then just to make that look nice, we write 2/3, and since it's the same exponent, 3 and 3, we can raise that to the 3rd power. So that is how you should write it. Okay, this means the same thing, but this is going to be how you'll want to write it from now on. Number 4, we have 9 to the negative 2nd power. So to get rid of that negative 2 exponent, the 9 base will go on top and a positive 2 exponent. Number 5, let me get rid of this. There. Oh, maybe not. The number 5, negative 4 raised to the 7th power. As you see here, the 7 is already positive. So we're going to keep that negative 4 raised to the 7th power right where it's at. Okay, that's good. We already have a positive exponent. but then multiplied by a -4 to the -9th power. This is where we have our issue. We don't want a -9. So this is going to go on the denominator. So our base stays -4, and that makes the 9 a positive exponent. And we're going to simplify this even more. We're not going to keep it like this because this is the same base. Okay, we just learned the quotient rule. When you have the same base, you subtract the exponent. You keep -4 as the base, and then you take 7 minus 9. You get -4 raised to the -2nd power. Again, we do not want a negative in the exponent, so we put it on the denominator. So we have -4 raised to the +2 power. Nothing's on the numerator, so we put 1 over -4 squared. Make sure you have these parentheses here. You need those. Number 6. Both of these exponents are negative, so they need to switch. So we will have 8. We switch the top one to the bottom. We will have 8 as our base. +5 is the exponent. If I switch the 8 to the -5 on the bottom to the top, we have 8 to the 5th power. 8 to the 5th power over 8 to the 5th power. That's the same number divided by each other, so it's going to end up being 1. We can also look at that as we have the same bases. We're using the quotient rule to subtract the exponents. 8 to the 5 minus 5 power is 8 to the 0 power, which is just 1. All right, the last two here. Number 7. First of all, this 4 needs to be distributed to the exponent of all the other numbers. So we are going to have 5 to the 4th power, x to the 2 times 4. Remember, a power to a power, you multiply. Y to the -3 times 4. And then z, this is a 1 right here. So we're going to have 1 times 4. 5 to the 4th power is 625. We have x to the 8th power, y to the -12. I'm just multiplying these out. And then we have z to the 4th power. The only problem here is we don't want this -12 as an exponent, so this term is going to go on the denominator. So our final answer will be 625. X to the 8th will stay on the numerator, z to the 4th will stay on the numerator, and then the y to the +12 on the denominator. And last one, lots of things going on here. And there's a couple ways you could do this, but I will show you how I would do this. So first of all, 4 over 12 are our coefficients. I'm going to keep that as 4 over 12. I'm going to get rid of the negative exponents. So m to the -2 power, that term is going to go on the denominator. So we're going to have m to the +2 power. Up top, n p cubed, that can stay on the numerator. In the denominator, we already have 12. This m squared stays on the denominator. Again, that's a difference. M squared than this one. This one came from the numerator. This one is on the denominator. N to the -5 power, we don't want negative. So we're going to put that n to the 5th power on the top. And then the p that's on this denominator here will stay on the denominator. And then you should see here that we have a couple of the same variables on the top. Okay, so n to the first, n to the fifth. We can combine that to n to the 1 plus 5 power. On top, we still have our 4 coefficients, and we still have p to the third power. All over, we have m and m that have the same base, so we add those exponents, so m to the 2 plus 2 power. So our 12 coefficients and our p. Okay, I'm going to keep going. 4 times n to the 6th, p to the 3rd, all over 12 m to the 4th times p. And I see one more issue here. That is that we have double of the same base, same variable here again. So p to the first power on the denominator, p to the third power on the numerator. This is a quotient rule. So we're going to take p to the 3 minus 1 power. Everything else stays. N, 4n to the 6th, 12m to the 4th on the denominator. We are almost there. The last thing we're going to need to do is just take care of this exponent. So our final answer will be 4n to the 6th, p to the second power, all over m for 12m to the 4th. Actually, there's one more step. I forgot about the coefficients here. 4 divided by 12. Okay, that simplifies to 1 over 3. And then n to the 6th, p squared on the numerator, m to the 4th on the denominator. And there you go. That is your final answer.